Hi all, Larry Feldman with a lesson on finding tangent lines using calculus. And what I drew on the screen is just some random function. I didn't even use a specific equation. I just drew a graph that is a function because it passes the vertical line test. And one stipulation here is that the function is differentiable at all points. And if we're going to find the equation of a tangent line of a function at a specific point, obviously the function needs to be differentiable at that point. So to make things easy, I made this function differentiable at all points, or all real numbers. So what do I mean when I say I want to find the equation of a tangent line and then graph it? So to illustrate the idea, let's just pick a point here on the graph, and I'm going to say that that's at A. In other words, x equals A. And if I want to draw a tangent line, I could do so. I could at least get an estimate of it, kind of like that, although I missed the point. So we'll cover up my mistake by making that point a little bit thicker. The idea is to find the equation of this tangent line when x equals A. So here we're going to go into a little theory, and going back to algebra, point slope form for a line is y minus y1 equals the slope times x minus x1. And we have a lot of this information. In fact, we have, or can find all of it in general, because this value of A is going to be our x1 point. So let's say this is x1 comma y1. In other words, x1, the x value of this point, is A. Now what is the y value? Well, the y value can be found if we know the value of the function, or if we know the equation of the function. The y value is simply f evaluated at x1, or using substitution, since x1 is equal to A, y is simply equal to, y1 is simply equal to f of A. Now, we have a point here, which written another way, other than x1, y1, we know it's also A, comma, f of A. Okay, so that's one piece of the puzzle. The next piece is we need the slope of that line. And luckily, we have an easy way to find the slope using calculus. M equals the derivative of the function evaluated at the x-coordinate, and the x-coordinate is A. So using all this information and going back to this equation, we have y minus y1 is f of A. That's equal to the slope m, which is f prime of A, times x minus x1, which is A. So this is the equation in point slope form, and we can manipulate it to get to slope intercept form in general, but let's leave it like this for now, and I'm going to clear the screen and then we'll do a couple examples. Okay, so I put the result at the top. This is the point slope form of the tangent line at A, f of A. And let's do an example. F of x equals x squared minus 4. And we're going to write the equation of the line. WEL is an abbreviation for write equation of line tangent to f of x when x equals 2. So this is the a value. So let's list all this information here. A equals 2. We need, going up to our equation, we need f of a. So f of a is simply f of 2, and f of 2 is evaluated by subbing in a 2 wherever there's an x. So we have 2 squared minus 4, which is 0. We also need f prime of a. So let's find f prime of x. The derivative of f of x is 2x. So now we have to find f prime of a. And again, a is 2, right there. And subbing in a 2 wherever there's an x gives us 2 times 2, which is 4. And that's the slope. So if we want to write the equation of the tangent line in point slope form, we get y minus, so we're looking up here, y minus f of a, which is 0, equals f prime of a, which is the slope of the tangent line, and that's 4 times x minus a, or x minus 2. Now, we don't need this, we don't need to write this 0, so we're going to just omit it, and we'll distribute this 4, so we get 4x minus 8. So let's write this up here. Y equals 4x minus 8. And we're going to graph f of x and graph the tangent line so that you can see that, that we're definitely in the ballpark. Let's first graph f of x. So we have f of x equals x squared minus 4. There are several ways to graph this, but one very easy way is to recognize that we can factor this as x minus 2x plus 2. That means that we have x-intercepts at 2 and negative 2. Now why is that? If x is 2, we sub in 2 here, this becomes 0. 0 times anything is 0, so this is an x-intercept, and this is an x-intercept, because if we sub in negative 2 here, negative 2 plus 2 is 0. We can get one other point if we want, which is the y-intercept, which we find by letting x equal 0. So let's come up to this equation. We can use either, but it's easier to use the top equation. If x is 0, we get 0 minus 4, or negative 4. So now we have 3 points. We have 2, 0, negative 2, 0, and 0, negative 4, which is like that. And we will make our parabola. We will attempt to make our parabola like so. And then let's go back to the original problem. We wanted the equation of the tangent line when x was equal to 2. So let's extend this y-axis down a little bit further. And we have 1, 2, 3, 4, 5, 6, 7, 8. Let's graph this tangent line. So what we're going to do is set up the ruler here to go through negative 8, which is right there. And we have a slope of 4. So we were going to go up 4 and over 1. So let's move this over a little bit. And let me draw this in. Let's see if this makes sense. Okay. So as I said, we have a y-intercept at negative 8. We go up 4, 1, 2, 3, 4, over 1. Up 4, 1, 2, 3, 4, over 1. So this is the graph of the tangent line, and this is the equation of the tangent line. And it seems to be reasonable because it passes through the function at exactly 1 point, and it does not cross from one side to the other. So let's do another example. So I will erase the screen. Let's say f of x is cosine of 3x, and we want to write the equation of the tangent line to f of x when x equals 0. So we need to, first of all, identify that a equals 0. That's our x value. We need to evaluate f of x when x equals 0. So f of 0 is cosine of 3 times 0, which is cosine of 0, and cosine of 0 is 1. So now we have our point. It's at 0, 1, right? 0, 1. We need the derivative of f of x. F prime of x is, what's the derivative of cosine of 3x? It is negative 3 times sine of 3x, right? The derivative of cosine is negative sine. Then we have the argument is 3x, so we need to take the derivative of the argument using the chain rule, and that brings the 3 into the equation, and we can put it out front. And now we need the derivative evaluated at a, so f prime of 0 is negative 3 times sine of 3 times 0, which is negative 3 times sine of 0, which is 0. Okay, so that means the slope is 0. So let's put this all together. We have y, let me change colors here. We have y minus y1 equals the slope times x minus x1. Now this is going to be a very simple example. We get y minus 1 equals 0, or y equals 1. So let's clear the screen, and we'll graph the function along with the tangent line. So I will do this offline, and I will be right back. So we will graph f of x first. If x is 0, we have cosine of 0, which is 1, so we have a point right there. And if x is pi over 3, let's sub that in here. F of pi over 3 is cosine of 3 times pi over 3, which is cosine of pi, which is negative 1. So we have a point here, and f of negative pi over 3, we could go through this, but cosine is an even function, so we know that this is going to be negative 1 as well. Even functions are symmetric about the y-axis, so this function, at least in this region, is going to look something like that. And now we have the tangent line. The tangent at x equals 0 is y equals 1. Now, a line of this form is horizontal, and if we graph this, let's put this up here, and that there, and let's graph y equals 1, which should look something like that. It's a little bit, looks like the slope is a little bit positive, but it's meant to be perfectly horizontal. So this seems to be a reasonable result. Our tangent line passes through one and only one point, and it does not cross the function. It does not go from the outside to the inside or vice versa. So this seems to be a reasonable result as well. I hope that was helpful. Please check out my website, www.lfeldman.com, for links to my mobile apps, which cover everything from algebra through calculus with hundreds of examples, tutorials, and solvers. See you next time. Thanks.